So let's see. Advanced functions. Alright, that's fine. So to show algebraically whether a function is even, odd, or neither, all you need to do is substitute negative x into the function. So you have to evaluate basically f of negative x. So now we have our function, which is negative 3x to the power of 4. But wherever you see an x, substitute negative x into it, and then simplify. My mouse is... this is not a good mouse. This is hurting me. Give me a second. Okay, so 3x, negative x to the power 4, then plus 6. You have negative x to the power of 2 minus 10. Sorry if it's messy. So whenever you have a negative x to an even exponent, basically that gets rid of that negative sign. So the first term is just negative 3x to the power of 4. The second term is just plus 6x squared. And negative 10 never changed because it didn't even have an x value. So this is exactly identical to the original function. You see that? So whenever you evaluate negative x, f of a negative x, and it's equal to the original function f of x, that is the definition of an even function. So if it would be different, let's say this exponent was 1. So then this would be negative 6x to the power of 1, right? And instead of being plus 6x, it's negative 6x, so that's different. Because it's different, then you have to see if it's odd or neither. In this specific case, if it's negative 3x to the 4 plus 6x minus 10, that's going to be neither. The reason being is because it has elements of both an even function, being x to the 4, and an odd function, x to the power of 1. And when you have elements of both even and odd together in one function, it's usually neither. If you had only elements of odd, like x to the 5 plus x to the 3, that would be an odd function. Or x squared and x to the 4, that would be an even function. Yeah, usually. I mean, that's an oversimplification. You have to do what I did, which is substitute negative x. But yeah, just as a kind of for your own self. Yeah, good to know. B is for what finite difference will f give a constant value, and what will that constant value be? So yeah, so it would be like the fourth difference because the highest power is 4, so it'd be the fourth finite difference. And what's the constant value? Do you remember how to figure that out? So the formula is FD equals A times N factorial, and A being your, leading coefficient. So that's negative 3. N being 4 for that fourth difference. And fourth factorial just means 4 times 3 times 2 times 1. So then the constant value is just this. So 2 times 3 is 6, 6 times 4 is 24, 24 times 3 is what, 72? No, maybe. I don't know. Do the math. Yeah. And then it's negative because it's negative 3. So the constant value should be negative 72, and the finite difference should be 4. And this is the formula we're using. FD equals A times N factorial. Are we doing C then? Sure. Was there any questions for B? You're good, right? All right. What are the maximum number of zeros the above polynomial could have? Maximum number of zeros. Okay, so we're talking about x-intercepts. That's what they mean by zeros. So we know the highest degree is 4. When the highest degree is 4, just so you know, a regular y equals x to the power 4 looks like this. Oh, looks like this. That's just y equals x to the power 4, y equals x squared. Any function like that with there's nothing else happening, it just looks like a parabola like that. Yeah. So, and in that case, it doesn't have to lie on the x-axis. It could also just be above or below. So that would be a minimum number of 0 zeros, because any even function doesn't have to have an thing is a x-intercept. So its minimum is 0, and the maximum it can have is 3. It's always the highest degree minus 1, yeah. So it's 3. Because it can be like 1, 2. Oh, no, I lied. I'm so sorry. It's 4. Yes. Yes, it's the degree. I'm sorry, I made a mistake there. It is 4, yes. So the maximum it can have is 4, which is, yes, the degree. And that's the answer. So this is exactly that formula that you mentioned earlier. FD is equal to A times n factorial. So they're looking for state the degree of the polynomial function that corresponds to each finite difference. Then determine the value of the leading coefficient for each polynomial function. So they're saying fifth differences. So the degree is obviously 5. So that's n. And negative 60 is this value fd. So negative 60 is equal to a times 5 factorial, which is 5 times 4 times 3 times 2 times 1. Which 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120. So this is going to be 120a is equal to negative 60. A is a half. Negative half. Yeah, that's the confusing part usually for a lot of students who are problems, trying to figure out exactly what they're trying to do. You want to do the next one then? You good? Okay, sure. All right, let's see. The table shows the percent of Canadian households that use the internet for electronic banking. So yeah, cool. Determine the average rate of change in percent of households that use internet for electronic banking from 1999 to 2003. You know how to do that? Okay. It's I'm sure you know how to do it. It's very simple. Yeah. It's just slope. Yeah, it's basic. This is not supposed to trick you. So just pick 2 points, and the 2 points they gave you, it's 1999 and 2003. Those are your 2 points for a year. And if you don't know, it's always the left-hand side of a table is usually your x, and the right side is y. So 1999, 2003 go here on the bottom. So that's 2003 minus 1999, and the top part is 30.8 minus 8. And what is that going to equal? What do you think? 22.8 divided by 4. And whatever that is equal to. 5.7 is average rate of change. What about B though? This is more difficult. Estimate the instantaneous rate of change in the percent of households that use the internet for electronic banking in the year 2000 and also in 2002. So do you know, what did your teacher teach you on how to do instantaneous rate of change? What techniques or methods did your teacher teach you? Okay, fine. So yeah, so let's take the average from 1999 and 2001. So go ahead and do that. It's just slope, basically.